Hello everybody. This is our video solution to problem 2 from Superquiz 2. And let's see, the instructions tell us that we're going to be computing an antiderivative, and we're going to use either integration by parts or partial fractions. So I don't see a fraction here, so integration by parts, that kind of looks like the right way to start here. So I want to compute an antiderivative for this function. I'm going to write this down, because I want whoever's reading, again, to know what it is I'm actually computing. All right, now I'm going to do my integration by parts on the side, and this looks like a good one to use the tabular method. Oh yeah, right. Every integration by parts is a good one to use the tabular method. Cool. Now let's see, I have a polynomial times an exponential. I really want to differentiate that polynomial because I know it's going to go to 0. So I'm going to put my polynomial on the left and my exponential on the right. And I'm going to differentiate my polynomial till I get to 0. So let's see here. We're going to get 6t minus 6, and then 6, and finally 0. And how about the exponential? Well, we have to anti-differentiate it. You might be tempted to do a substitution, but that's kind of a waste of time here because this is just composed with a linear function. So I know I can just copy the exponential, and I can just check, like, what would happen if I differentiated this? Well, I'd get this back, but then I'd have to use the chain rule, which would give me an extra factor of 3. So to compensate, I divide by 3, right? This is always the trick when you compose with a linear function. Just write down what you would think it would be if you hadn't composed, and then divide by whatever coefficient you get in front of t. So for the next one, I'll just divide by 3 again. So 1/9 e to the 3t minus 7, and finally 1/27 e to the 3t minus 7. All right, I connect diagonally, plus minus plus, and we're ready to roll here, right? So I notice first each one of these is going to have an exponential, so I'm just going to factor that out. So we're going to get e to the 3t minus 7, and then what's left over? So we have a third times 3t squared minus 6t plus 11. Then we have minus a ninth times 6t minus 6, and then plus a 27th times 6. All right, so we'll write here 6 over 27. And I could keep going. I could distribute things. Maybe there's a lot of simplifications, but I don't want to, and you can't make me, right? The more steps I do here, the more likely I'm going to make a mistake. And certainly on an exam, I don't want to make any mistakes I don't have to make. So let's just leave well enough alone. All right, well, we will see you next time in problem 2b.